Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. Today's lesson, we will talk about kinematics and measurements. This is our second lesson on kinematics and measurement questions from Cambridge AS Physics past papers. Here is our first question for today's class. Let's try to see what is given to us and what we need to find. If we read this question carefully, we can simply find out the four students, they did one experiment and they made a series of measurements to find the value of G. Means free fall simply means we ignore air resistance. So what we need to find out, we need to find out which set of measurements is precise and which one is not accurate. Means which set is the option A, B, C, D is precise but not accurate. So to answer this question, we need to understand the exact meaning of precise and accurate. So let me explain to you what exactly is precise and what exactly is accurate. So the precise, as you can see here, I have already written for you to save our time and to finish this video quickly. As you can see, precise means that the measurements are close to each other. So what exactly it means? So let me give you one example. Let's say we have two sets of data. Let's say one set is 24.1 and 24.2. Another set of data, let's say we have 24.0 and 24.4. Now we need to find out which set of measurements is more precise. So means we just need to find out which measurements are close to each other. So one way to determine that can be we find the difference between them. We can find out 24.2 minus 24.1. As you can see, the difference between these two values is equal to 0.1. And if we find the difference for the second set, we can find out 24.4 minus 24.0. The difference between them is equal to 0.4. So from here we can simply conclude that this set is more precise. So this is what exactly precision is. So this set is more precise. So based on this one, we will determine which option is more precise. Okay, the second thing we need to understand, accurate. So what's meaning of accurate? Accurate, we can also understand simply accurate means correct. So this is common language, means correct. So what exactly means? The measured value is close to actual value. So it simply means that the actual value of anything is equal to, is close to, not exactly equal. So we can say actual is equal to measured value. So what exactly it means? So let me give you one simple example. So example can be, as you can see, the actual value of G. So this one is the actual value of G. Actual value of G is equal to 9.81. Let's say we got two measurements. We got one measured value. I will just simply say MES. Let's say we got one is 9.7 and other one we got that is, let's say, is 9.6. So make it simple. So which one is more accurate? Accurate means which one is closer. Simply it means which one is closer to 9.81. As you can see, 9.7 is closer to 9.81. So we will say this one is more accurate. So we can say this one is more accurate. So this is how we can determine accurate. So this one we will say is not accurate because it is not close to 9.81. Now we understand what exactly is precise, means the meaning of precise, and also we understand meaning of accurate. So let's try to answer this question now. So it means now let's try to find out the best possible option. Best possible option, let's try to find out. If we look at option A, as you can see here, 9.81, 9.79, 9.84, 9.8. These values are very close to each other. So we can say that these values are precise. And also they are close to 9.81. We can also say these values are accurate as well. But this is not our answer because our answer has to be, measurements has to be precise but not accurate. So this is not best possible answer. If we look at option B now, you can see the first one is 9.81. This is 12.12 is greater than, but this is 9.89 is still close to 9.81, and this is 8.94. So this is close to, this is exactly 9.81, but these values are greater than 9.81. So overall result will be greater than 9.81, but still is close to 9.81. So we can say that this is accurate. So this result is accurate as compared with the others. So we can say this is accurate. And as the values are away from each other, you can see the difference between 10.12 and the smallest one, 9.81. So we can say is not precise. So it can be accurate, but it is not precise. But if we look at this option now, you can see 9.45, 9.81 or 9.21, 8.99, 8.76, and all of these values are smaller than 9.81. This set of value is not accurate. Actually, there is a kind of systematic error. So but if you're not clear about systematic error, no problem, but due to systematic error you can see a trend. All the values are just smaller than 9.81. So there is systematic error. If you didn't remember what is systematic error, no need to worry. So we can simply say this is not accurate. So we can say this one is not accurate. But also we can see this is 9.45 and 8.99. There is a big difference as compared with other values. We can say this is not accurate, but this is also not precise. Now the last one, so this is also not our best possible option. This is also not best possible option. But if you look at this one now, you can see this is 8.45 and this is 8.46, very close, 8.50 very close, and 8.41. Even all these values are smaller, there is also systematic error because all these values are just lying on one side of actual value. So there is also systematic error. So we can say these values are precise because they are close to each other, but these values are not accurate because they are not close to 9.81. So our best possible option for this question is D. For this question, it is given to us that a football is dropped from the top of a tall building. So this is important, from the top of a tall building. And also it is given to us that the air resistance is not negligible. So for this type of question, we need to check always for air resistance. Is the air resistance is negligible or not? For this question, air resistance is not negligible. So now the next thing what we need to understand is that if the building is tall enough and air resistance is not negligible. So what we can assume from that? So we can simply assume that the football will finally reach terminal velocity. So this is the first thing we need to conclude from given information. Now we understand the football will reach terminal velocity, so we can sketch velocity versus time graph. As you can see, the velocity on a y-axis, and we can sketch time on x-axis. So if we sketch this graph, this is kind of typical graph at AS level physics. So the graph will look like this. So finally you can see the gradient becomes zero. So from this one, if you look at this point, the gradient means the m is maximum. So we can say value of a is also maximum. And finally, the gradient is equal to zero. So we can also say that acceleration is equal to zero. So one thing I need to explain to you is that gradient of velocity time graph, that is equal to gradient of velocity time graph is equal to is equal to a mean is equal to acceleration. That's reason we said when the gradient is maximum, it means a is maximum, and when gradient is zero, it means a is zero, because the gradient of vt graph is equal to a. Now if we have this understanding, and now we can find the best possible option. Now and also we need to understand a is not uniform. A is not uniform. It's non-uniform because its value is changing with time. So we can also say A is non-uniform. Now if you look at this one, at the beginning, A has to be maximum, but this one is telling you A is equal to zero. So this is not best option. Okay, option B, if you look at this one is simply telling us that A is maximum, but it is not changing with time. So it's telling us simply that A is uniform, means A is constant. So this is also not best possible option. If you look at D, as you can see here, is also telling you that A is maximum. It's telling you A is zero, but at the beginning A is maximum. So A is zero, this is simply telling you. So this is also not best possible option. So if you look at C, option C, now at the beginning A is maximum, and at the end finally A is equal to zero. So this is according to this. So simply we can conclude or answer, best possible answer for this question is C. Okay, so this is our next question. So let's try to find out what is given to us. First of all, it is given to us that the horizontal component is equal to 20 newtons and angle is also given. So what we need to find out, simply we need to find out vertical component. As you can see, this diagram is also given. The vertical component is on y-axis and horizontal component is on x-axis. So let's try to answer this one now. So I can sketch this one in a little different way. So I can say this is the vertical component. So it's look more familiar. So now how we can find the value of vertical component? So I will simply say horizontal component, let's say as this is the force actually, so the better way is that I also use F here. So this is the force. Now I can say that F at the horizontal component of force will be equal to F cosine of given angle. So if this is as Fh is given to us, that is equal to 20 newtons, 20.0 newtons. So from here we can also write down here that f cosine of 30 degrees, that is equal to 20.0 newtons. So we can find out the value of f. So simply we need to divide 20 by cosine of 30 degrees. If we divide this one, we will get force is equal to 23.1 newtons. So we can update this one. So this is value of 23.1 and this is value of resultant force. Now we need to find the vertical component of force. That is quite straightforward one, that FV means the vertical component will be equal to F sine of given angle, means this angle. In this case, this angle is given. This is equal to 30 degrees. So simply we just need to plug in these values and we will get our final answer. So our final answer for this question will be 11.5 newtons. So this is what we need to find out, vertical component. So our answer is C. For this question, velocity time graph is given to us. As you can see here, the velocity time graph is given. Velocity versus time graph is given. In this case, the car is just moving in a straight line. So it means distance and displacement are the same. So what we need to find out, we need to find out the distance versus time graph we need to find. So how we can answer this question? So the first thing we need to understand is that gradient of displacement time graph, the gradient of dt graph is equal to velocity. So the gradient of displacement time graph is equal to velocity. So now we need to find out, as the velocity is constant here, so from this point to this point the velocity is constant. So it simply means that the gradient of dt graph has to be constant. The gradient of dt graph has to be constant. So this is a gradient of dt graph, mean distance against time graph. As you can see here, the velocity is decreasing. So here we can also say as the velocity is constant. So this is from t0 to t1. So from t1 to t2, so as you can see here, the velocity is decreasing. So it's simply telling us the gradient also has to decrease with time. So this is what, if we have this understanding, then we can answer. Now if you look at option A, so this is simply telling us that this is same, s is not changing with time. So this is absolutely not possible answer. So this is not possible. So it means simply object is at rest, mean the velocity is equal to 0. So this is not possible answer. If we look at this one, so the first one is telling us that the velocity is constant. Velocity is constant, but the second part is also telling us that the velocity is constant because the gradient is constant. So this is also not possible answer, because the gradient is constant. Actually gradient in the second part from t1 to t2 has to decrease. So this is not possible answer. Now if we look at C, now at the beginning you can see the gradient is constant. After that the gradient is decreasing. So you can see here, first of all, m has to be constant. So m has to be constant. So this is true here, m is constant. So this one is true. And after you can see the gradient is decreasing, means the velocity is decreasing. So that is also true. So this can be our answer. So let's also look at option D now. As you can see, gradient constant and is increasing. So this is not possible answer. So our best possible answer for this question is C. this is last question for today's class, so let's try to find out what is given to us. For this question, it is given to us that a resistance can be ignored. So this is the first thing we need to understand. So what we need to find out, we need to find out the changes in horizontal and vertical components of golf ball's velocity. So we need to simply understand when velocity will change if there is force is acting on the object, means there is a resultant force acting, then its velocity will change. So as a resistance is, it can be ignored, it simply means that along horizontal, so we can say along horizontal there is no force. So along horizontal there is no force, so it simply tells us that vh will be constant. So vh will stay constant, the horizontal component will not change. And along vertical means in downward direction, as the gravity is acting down, so the force is acting means the gravity is the resultant force that is acting along vertical, and gravity is acting downward, so we can also write down gravity is acting downward. So it means that there will be vertical acceleration, so due to that one vertical velocity will change. So this will not be constant, or we can simply say object will be accelerating vertically downwards. So if we have this understanding, and this is also the basic concept about projectile motion, so then it is quite straightforward to find our final answer. So as velocity is constant, we can also say horizontal acceleration is equal to 0. And so the vertical acceleration will be equal to g because there is no air resistance. Now let's try to find out answer. Constant deceleration, so this is not possible because a at has to be equal to 0. Constant deceleration, this is also not possible. Constant velocity is possible, so this is correct. Constant acceleration downward, this is also correct. So it means our best possible answer is C. Let's look at part D as well. Constant velocity, that makes sense. Acceleration decreases upwards, that is wrong. So D is not answer, D is not answer, C is our answer for this question.